Science has always attracted me. Like so many kids, I went through a bunch of phases. A dinosaur phase, a chemistry phase, an astronomy cosmology phase. I read anything I could get my hands on. I asked my parents to take me to libraries, museums, exhibitions. I generally ignored my teachers because I thought I knew more than them. The simplicity, the beauty, the elegance of scientific descriptions, models, and explanations spoke to me. Now, after a brief and very unsuccessful career as an engineer, I became a physics teacher. To use my expertise to serve a higher purpose, to promote the lifelong flourishing of students by equipping them with scientific knowledge, skills, and understandings that will serve them well throughout life. Now, as a teacher and student of science, physics, it's very easy to get lost in the nitty-gritty details of the field. Formulas like Newton's second law, the ideal gas law, Einstein's E equals mc squared. Standard problems like Atwood machines, realistic pendulums, and magnetic dipoles. And all those tedious calculations using trig, calc, algebra. It's easy to lose sight of the bigger picture. So today I want to talk to you about three brief, but big lessons I took away from teaching and studying physics. No formulas, no homework, no exams, I promise. Students of physics very early on learn to make certain assumptions. Assume air resistance and friction are negligible. Assume bodies are point masses. More generally, assume the universe is real, regular, and predictable. Physicists make assumptions all the time when they construct scientific models, simplified representations of reality. And good physicists are very open and transparent about these assumptions. And as long as observations and experimental results confirm these assumptions, all is good. But as soon as compelling empirical evidence starts to contradict these assumptions, the assumptions are either modified or dropped altogether. The ether, the caloric, phlogiston are just a few examples of wrong assumptions that have now been almost forgotten. A current assumption is that the speed of light is constant. Now maybe that's an assumption that one day will be dropped too. In fact, Einstein himself considered theories with a variable speed of light. Now, in school, I had a hard time getting economics. I did really well on exams, but there was something about the subject that rubbed me the wrong way. It took me a while to understand that was because the underlying assumptions of economics just made no sense to me. Humans make rational decisions. Have these economists ever met a real person, I thought? Money developed because barter and trade are too cumbersome. In his book, Debt, the First 5,000 Years, anthropologist David Graeber writes, there is zero evidence that any culture ever bartered amongst themselves for any meaningful period of time. Adam Smith basically pulled that one out of thin air. Markets guarantee optimal distribution of scarce resources. Evidence from healthcare, education, culture systems around the world show otherwise. Now, behavioral, biophysical, and ecological economists have updated their assumptions to better fit reality by integrating certain concepts of physics. Now, unless all economists do this, I expect mainstream economics to end up like astrology. That's reading the future in the stars. Pseudoscientific nonsense based on false premises. So, what physics teaches me is to always ask what the assumptions of a field of knowledge are, and whether those assumptions make any sense. So ask yourself, what are the explicit, but especially the hidden assumptions of the field you're interested in or working in? The laws of physics describe fundamental limits to what is possible. Laws like the laws of conservation of mass, energy, charge, momentum. The second law of thermodynamics constrain reality. Nowhere is this more clear than in the global predicament we find ourselves in. Just look at reports like the ones from the IPCC, Intergovernmental Panel on Climate Change. Global industrial civilization is in ecological overshoot. We are running into hard biophysical limits. Now, despite what some, if not most, business people, economists, politicians might claim, there are limits to growth on a finite planet. In school, I had a hard time understanding history. I did well on exams, but there was something about the subject that rubbed me the wrong way. And it took me a while to realize that was because of the way history, as I learned it at school, seemed to almost completely separate humans from the Earth system. Why is it that I didn't learn in school how war and the decline and collapse of complex civilizations is almost always very closely related to resource depletion, climate change, natural disasters? Why didn't I learn how coal displaced slaves as the main source of energy in certain societies? How an Icelandic volcano helped spark the French Revolution? Yes, we live in a society, but we also live in an ecosystem, at least for now. Humans and the Earth system, human systems and the Earth system are integrated, not separated. Just look at energy. Physics tells us that energy constrains how much a system can change. And empirical evidence indeed shows a very strong correlation between economic growth and energy use. Now, modern global industrial civilization depends on three main sources of energy: sunlight, fossil fuels, and the atom. Now, all three of those have their own advantages and drawbacks. Now, it's perfectly clear for anyone willing to see that the continued use of oil, coal, natural gas is civilizational suicide. So there's a lot of talk about renewables. Now, look at the data. The growth in renewables is less than the global growth in energy demand overall. So renewables grow less fast than energy use altogether. So what about sunlight? Sunlight's sustainable. Now, the problem with sunlight is that it's very diffuse. You can't make steel, aluminum, and concrete with sunlight. You can't power trains, planes, rocket ships with sunlight. You can't build solar panels, wind turbines, or nuclear power plants with sunlight. Just plain physics. So what about decoupling? You hear about decoupling of economic growth and energy use. Again, zero empirical evidence this is happening. Physics is clear. Energy means change. So there's no evidence. Economic growth can be separated from energy use. Just look at, if you take one example, how much energy the digital realm uses. Things like the global Bitcoin network consume more energy than countries like Sweden, Argentina, New Zealand. In any case, the second law of thermodynamics is clear. Every time you take high quality, concentrated, useful, low entropy energy, it turns into low quality, useless, high entropy energy in the form of heat. Now, physicist Thomas Murphy writes about this on his blog, Do the Math, and also in his terrific textbook called Energy and Human Emissions on a Finite Planet. He describes how the only way for Earth to get rid of this heat is infrared radiation. Physicists understand this problem very well, and they can make predictions of Earth's surface temperature based on energy use with straightforward physics. It turns out that with an average annual growth rate of only 2.3%, Earth's surface reaches 100 degrees Celsius in less than 4 centuries. And this is plain physics. This is independent of technology. So forget about the idea that new technologies and human ingenuity will save us. Now, even Adam Smith knew this. Adam Smith wrote that economic growth is a transient phenomenon, it's just a blip. Now, Adam Smith thought it was limited by land use, land being the main source of energy in his time. So what physics teaches me is to always ask myself what the limits of a system are. Limits that come from the fundamental properties of our universe. Now ask yourself, what are the limits in the field you're interested in or you're working in? I am become death, destroyer of worlds, said theoretical physicist Robert Oppenheimer when he witnessed the Trinity test, the first successful detonation of an atomic bomb, New Mexico, July 1945, less than a month before the destruction of Hiroshima and Nagasaki. An understanding of physics can make you feel powerful like a god, or insignificant like a speck of dust. To me, it's the second one. Every new discovery we make in physics removes humans from the center of the universe. Know your tribe is not the center of the universe, nor is your culture or your country, nor is humanity or Earth or the Sun or the Milky Way galaxy or the local group cluster or the Virgo supercluster lobe or the Laniakea supercluster. Ever larger cosmic structures we live in. It's turtles all the way down. Exceptionally beautiful turtles, I might add. Now, this is something I learned in school. I did pick up the centrifugal forces that remove humans from the center of the cosmos. Now, I find this very liberating. It's an antidote to hubris. Hubris, excessive pride or self-confidence. There is currently no reason to assume humans are necessary for the existence of the universe. We're just a bunch of meat sacks living in a thin film on the surface of a watery planet, a pale blue dot in an unremarkable galaxy, in an out-of-the-way corner of just one universe, part of a larger multiverse. Recognize him? Sisyphus. Sisyphus is a character from Greek mythology. Having cheated death twice, he was punished by Zeus to forever roll a boulder up a hill in the depths of hell. And every time Sisyphus managed to get the boulder, the rock up the hill, the rock would roll back down, forcing Sisyphus to start all over again, from here to eternity. Now, French writer Albert Camus wrote that, giving the meaninglessness and absurdity of his life, one must imagine Sisyphus happy. Now, that's what my layman understanding of physics and cosmology makes me feel. I feel joyful and optimistic, not despite the meaninglessness and absurdity of human life, but because of it. So what physics teaches me is that nothing really matters. So I'm free to choose what matters to me. I'm free to choose what gives meaning to my life. Now ask yourself, where is the hubris, the beauty, the meaning in the field you're interested in or working in? Physics is a study of the fundamental properties of the universe we live in. Other fields of knowledge that claim to have anything to say about our place in the universe should adhere to the laws of physics to be relevant. When fields of knowledge separate themselves completely from the laws of physics, at best you get entertainment like astronomy or Myers-Briggs. Sorry, did I say astronomy? Of course I meant astrology. Or maybe you just get pretty harmless pseudoscience like, homeopathy, psychoanalysis. Much more harmful are ideologies pretending to be scientific, like eugenics, social Darwinism, that thing that starts with an M, and neoclassical economics. So whether you plan to become a business person or economist, historian or journalist, teacher or politician, I strongly recommend that you study the basics of physics. Start with conservation laws and the second law of thermodynamics. It will make you better at detecting bullshit, avoid being misled, but more importantly, live a life of beauty, contentment, and meaning. Thanks for listening.